In this example, we're going to do synthetic division with a fourth degree polynomial of 6x to the fourth minus 22x cubed minus 9x squared plus 9x minus 17. And we're going to divide by the binomial x minus 4. And so what I'm going to do is I see all my exponents are in decreasing order. I have no gaps. And so I'm going to put my coefficients down, 6, negative 22, negative 9, 9, and negative 17. Leave a space, leave a row, my line down, and put a box for where my remainder is going to go. And now I need to look at what my R value is and put it in this little corner box. X minus 4, so it's the opposite of what I see, so my R value is a positive 4. Put it in the box, and now I can do synthetic division. You drop the first term. Multiply, 4 times 6 is 24. Add vertically, negative 22 and 24 is positive 2. Multiply by 4, I get 8. Add vertically, I get negative 1. Multiply negative 1 and 4, I get negative 4. Add 9 and negative 4, I get 5. Multiply by 4, I get 20. Add vertically, negative 17, and 20 is a positive 3. So now I need to write down what the polynomial I see here in blue is. The coefficients of 6, 2, negative 1, and 5. Remember, this means my exponents are in decreasing order where my last number starts with my constant. So that's a positive 5. Negative 1 is the coefficient for my x term. So negative 1x is just negative x. 2 is the coefficient for my x squared term. So that's a positive 2x squared. And 6 is the coefficient for my x cubed term. And now I take in consideration my remainder. It's a positive 3, so plus 3 over what I divided by, which was x minus 4. And so that is the solution. Now we can also look at a little shortcut if you don't want to go backwards every time with writing your polynomial like I did with the 5, the negative x, then the 2x squared, then the 6x cubed. Look for the pattern. We have 4 terms, and so we have a degree of 3. And so your degree in your answer is going to be 1 less than the terms outside of our remainder box. So since we have 4 terms, the 6 is for an x cubed. The 2 then would be going down x squared, negative 1 for the x, 5 for the constant. So in the next example, I'm going to try and use that shortcut instead of going backwards for it. So in this example, we have 2x squared plus 5x minus 3. My exponents are in decreasing order. Every exponent's accounted for. There's no gaps. So I'm going to write down my coefficients of 2, 5, and negative 3. Leave my row and put my remainder box. Now I'm going to find my R value and put it in this little corner box. It's the opposite of what I see. X plus 3, that means your R is a negative 3. Drop down the first term. Negative 3 times 2 is negative 6. 5 and negative 6 is negative 1. Negative 3 and negative 1 is positive 3. Negative 3 plus 3 is 0, and so 0 is my remainder. I have 2 terms, and so my degree is 1 less. Degree of the first term is 1 less than what I see. So 1 less of 2 is 1, so this 2 belongs to an x to the first power, which is just x, minus 1. Since the remainder is 0, I don't have to take it into consideration. And so the answer when I divide 2x squared plus 5x minus 3 by the binomial x plus 3 is 2x minus 1. And so we see the pattern holds when doing synthetic division to drop down the first term, multiply diagonally, put your answer diagonally, add vertically. If you can't remember the shortcut for writing your polynomial, then just work backwards. Negative 1s are constant. 2 is the coefficient of the x term. So 2x minus 1.